Okay, so in this solution video, I'm going to go through carefully particle motion in both types of, two types of representations. The first representation will be given a graph, and the second one will be given a function, so kind of algebraic and graphically. So this first problem here in assignment 28 is the graph. So we're given a graph of, hopefully this is working, the position of a particle moving along a number line as a function of time t. So this is t measured in seconds, and this is its position on the number line. So that means at time t equals 0, the particle is at the origin. And say, for example, at time 2.5 seconds, the particle is back at the origin. And at time t equals 3, the particle is at -2 on the number line. And it seems that from 3 to 4 to 5 seconds, that the particle has not moved because it remains at -2 during those times. And at time t equals 6, the particle is at -4. So let's just make sure we understand what that graph means. We want to figure out the values of t from 0 to 6 from when the particle is moving right. So that's a trigger word. Moving right means that the velocity has to be greater than 0. We know that the derivative of position equals velocity. So that means when I take the derivative of s, which is a graph, I'm going to look at the sine of the slope, the sine of the tangent line. And I want to look for when that slope is positive, because when velocity is positive, the particle is moving to the right. So here I have a positive slope. This here is a zero slope, negative slope, zero slope, and negative slope. All right, let me just hide this again. So when are my slopes positive here? It looks to be only from 0 to 1. And you know what? We're going to avoid um, the endpoints there. So we're just going to have open parentheses. On what interval is the particle moving left? So moving left triggers when v is less than 0. And remember, s prime equals v. So we want to look at the slope. This means the slope of the graph of s. And that seems to be negative from 2 to 3, and as well as from 5 to 6. And on what intervals is the particle at rest? Well, at rest triggers velocity equals 0. So when does the slope of s equal 0? And the particle is not moving from 1 to 2 and from 3 to 5. The next one. What's different here is we're given v. So again, it's a graphical representation of particle motion, but this time it's time versus velocity. And remember, velocity is directional. So when velocity is 0, the particle is not moving. When the velocity is positive, the particle is moving right or is moving up. And when the velocity is negative, the particle is moving left or is moving down. So the first question is, when is the particle at rest? That triggers when velocity equals 0. Well, I'm given the graph of v. So the velocity equals 0 at time t equals 0, 2, 7, and 10. We're just going to bank on that here, guys, being 7. When does the particle reverse direction? Is when velocity changes signs. So velocity changes signs at, so this is a, this is a positive here to a negative. So that's at time t equals 2. And then velocity also changes signs at time t equals 7. So you have to be careful here because the graph of velocity is given. So from here to here, the graph of velocity is all positive, but then it switches from positive to negative at time t equals 2. And then over here at 7, the graph of velocity changes from negative to positive. So that's where the particle is reversing direction. On what intervals is the particle moving right? So it's moving right when velocity is greater than 0. So once again, when are we given the graph of velocity above the x-axis? That would be from 0 to 2, and as well as from 7 to 10. When is it moving left? When velocity is less than 0. And by the graph here, the velocity is below the x-axis from 2 to 7. And last, we have our common questions here of speeding up or slowing down, and that is where we have to compare the signs when they're the same or different. So the particle is speeding up when v and a are the same. Okay, so then now we have here, I'm looking here. So here, this is helpful. Trying to erase, and then it's like flickering here. Okay. So let's do this. Velocity is all positive here, and velocity is negative here, and it's still negative there, still negative, positive, positive. So on one side, I have velocity labeled. But now for acceleration, I'm going to label the sign of the slope. So this slope is positive. This slope is negative. This slope is negative still, but this slope is 0. This slope is positive, this slope is positive, and this slope is negative. So on one side, I have the sign of velocity from the graph, and on the other side, I have the slope, which represents acceleration. So when do v and a have the same sign? Well, it's happening from 0 to 1, because that's going to be halfway. So from 0 to 1, both v and a are positive, and as well as from 2 to 3, and as well as from 7 to 8. That's where v and a have the same sign. The particle is slowing down when v and a are opposite signs, because we have to justify our answers. So I see from the graph that right here, v, I should have put the negative on the other side then, I guess. But v and a are opposite signs from 2 to, oh, no, not 2, but let's say 1 to 2. Because from here at 1, again, velocity is positive, but the slope is negative for acceleration, so it's slowing down there. Here, they're both negative. 0 is neutral. 0 is neither positive nor negative, so that doesn't count. And here, this is where velocity is negative, but acceleration is positive, so it's from 6 to 7. And then here, I have velocity is positive, acceleration is negative, and it's going to be happening from 8 to 10. So those are my intervals where both the particle is speeding up and slowing down. In the next graph, I'm not sure if we can answer everything. Okay, so now in this third graph, I guess what we have is just a picture of velocity. And here the given information kind of confirms that we've got these horizontal tangents at 1, because sometimes they'd be hard to see, and as well as at 4. Okay. It does cross through the axis at 0, 3, and 5, but remember now this is velocity, not position. So from 0 to 6, when is the particle moving right? So it's moving right when the velocity is positive. Since we're given the graph of velocity, it is positive strictly from 3 to 5. When are we moving left is when velocity is less than 0, and that's happening from 0 to 3, as well as from 5 to 6. And from 0 to 6 now, when is the particle at rest? Is when velocity equals 0. So that's at time t equals 0, 3, and 5. Why? Because velocity equals 0. Remember, this is the graph of velocity. This is when velocity equals 0. This is when velocity is greater than 0. and this is when velocity is less than 0. So that would mean this is when we're moving right, when we're above the x-axis. This is when we're moving left, and this is when we'd be at rest. When does the particle reverse direction? That happens when velocity changes signs. So velocity here goes from negative to positive at time t equals 3. And it also goes from positive to negative at time t equals 5. For what values is the acceleration positive? The acceleration, v prime equals a. So how do I get to acceleration given the graph of v? I have to take its derivative. And the first derivative of a graph is the sine of the slope. So here, all my slopes are negative, slope is 0, all slopes are positive, and then all slopes are negative. Okay, so when's my acceleration positive? Where my slopes are positive, and that is happening from 1 to 4. Maybe I should pick which side I'm going on here on, right? And that's when v prime equals a is greater than 0. Likewise, we could see that the acceleration would be negative when velocity, the derivative of velocity, is less than 0. So when are the slopes of v less than 0? This means to take the slope of that. So then this here would be from 0 to 1, and then from 4 to 6, if that were the question. And the last one's a very common question again, for when is the particle speeding up or slowing down. For speeding up, we want v and a to have the same sign, and slowing down, v and a are opposites. So once again, let me just get, it doesn't matter, I guess, which side you want, but just pick a side for one graph, for one function. So here, what I'm going to do again here is my velocity here is all negative, 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 positive, 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 and then negative, negative, negative. Okay, that's where my velocity are those signs. And then now acceleration is the sign of the tangent. So here, all my slopes are positive, and that's 0. Whoa, no. Boy, I'm falling asleep. Negative, negative, negative. Here, all my slopes are what? Positive, positive, positive. And then here, all my slopes are negative. Okay, so once again, acceleration is the sign of the slope of the tangent line. So here, all my slopes are negative, guys. And here, all my slopes are positive. And here, all my slopes are negative. So let's compare when they are the same. So they're speeding up from 0 to 1 because I see both of these are the same. And it looks like also to me from 3 to 4. And as well as from 5 to 6. So that's where that's when the particle is speeding up, because velocity and acceleration have the same sign. Here, when is the particle slowing down? That's when v and a have opposite signs. And that's happening from 1 to 3, I could see. And then as well as from 4 to 5 is where those signs are opposite. So once again, you have the graph of velocity. When the velocity is above the x-axis, the sign is positive. When it's below the x-axis, velocity is negative. But in order to arrive at acceleration, you have to take the derivative of velocity, and graphically, that is the sign of the tangent line there. The other ones you cannot answer at this point. And number 4, to go through this here, again, this is the analytical interpretation. So average velocity, that's a trigger word. That means the position at 4 minus the position at 0 over 4 minus 0. And you can put this into your calculator into y1 and evaluate that at 4 and 0. And that's going to come out to be negative 6 2/3 divided by 4. And I think I got that to be simplified to negative 1 2/3. The rest of the questions involve the derivative. So if this is position, to answer anything about at rest, reversing direction, or moving right or left, I need to get to velocity. So S prime at t equals V at t. And by this nice power rule, I'll drop down the power, the 3's will divide out, and I'm left with t squared minus 2t plus 3. Set the velocity equal to 0. I'm going to reverse FOIL here, and I'll get t equals 3 and t equals 1. Remember, that's velocity. Make a number line at 1 and 3. Now, we are on a closed interval from 0 to 6, so we got to close that off. So when I test out velocity, I'm going to pick a test point like 1/2. I'm going to put that time into here. So a half minus 3 is a negative, and a half minus 1 is a negative. A negative times a negative is a positive. If I pick, say, 2, 2 minus 3 is a negative, 2 minus 1 is a positive, and a negative times a positive is a negative. And if I pick, say, here, 5, 5 minus 3 is a positive, and 5 minus 1 is a positive, so therefore my number line is positive there. So I have my answers. When is the particle at rest? When velocity equals 0, and that is at time t equals 3 and t equals 1. When is the particle reverse direction? When velocity changes signs, and that's happening at time t equals 1 and t equals 3. When is the particle moving right? That is when velocity is greater than 0. So here it's going to be from 0 to 1, but the bracket matters here now, because at time t equals 0, which is included, 0 minus 3 is a negative, and 0 minus 1 is also a negative, and a negative times a negative is a positive. So when the velocity is positive, the particle is moving. So it's got to be included. And when is it also moving right? From 3 to 6. But again, 6 is going to get included. So the bottom line is you just don't include the critical points, but we'll include the endpoints. When is the particle moving left? That's when velocity is negative, and that's happening from 1 to 3. And now to answer the questions of when it's speeding up and slowing down, we need to get to acceleration. So v prime at t is equal to a at t, which is 2t minus 2. I'm going to set acceleration equal to 0. I'm going to get t equals 1. Do a number line test on that. So then if I pick 0, 0 in for t produces a negative. Pick, say, 2, 2 in for t produces a positive. So then now I have to tuck in 1 with my number line from velocity. So I'm just going to rewrite this maybe over real fast. Doesn't have to be, because that's my endpoint. And this is 0, and velocity was, had those signs on those intervals. These were the signs of velocity. When I tuck in acceleration, 1 is already over here. So I don't need to break it up anymore. So I'm going to put acceleration above, and acceleration is negative to the left of 1. But to the right of 1, it's all positive. And there I have my answers. When velocity has the same sign, the particle is speeding up. So it is speeding up. You got to be careful. I had a different sign there, but I have positive, positive, and velocity should be positive, negative, positive. Yeah. So here, yeah, that's probably wrong in my solutions. I don't know why I had here. I think in my solutions I had a negative before, but it's clearly a positive. So it is speeding up only from 3 to 6 with a bracket at 6, because 6 was not a critical point. And it's slowing down, bracket at 0, parenthesis at 1, and then from 1 to 3, parenthesis. Again, the parentheses will always be at the critical points, because that's where the velocity or acceleration equals 0, and 0 is a neutral sign. 0 and 6 were not critical points, so therefore we can include them because the functions did take on those signs. The justification is here. V and A are opposite signs, and here V and A are the same. Okay, they are the same. Yes, and I think in my solutions there, this here should have been a positive. I don't know why that had a negative. And then in part E, the distance traveled right here using your calculator. So again, the problem is with room here. In part E, you need the position at 0. And you plug that in easily into here, you get 4. And then your critical point at 3, S at 3 is -5. And then you need to figure out S at 1, and then S at 4. And I'll leave that for you to do. So you need to figure out S at 0, which is 4. You need to figure out S at 1. S at 3 is -5. And S at 4, which was -2 and 2/3. And take the difference in those positions, add them up, and that's the total distance traveled in that. Okay, so again, I hope that helps, and sorry about the little mess up maybe on my hard copy, but those right there are opposite signs. So the particle is slowing down from 0 to 1 as well as 1 to 3 because V and A have opposite signs. And over here it's the same sign, so it's speeding up. So there you got the two representations, everyone, both graphical and analytical.